So now we're going to move on to the TI-84 Plus. So we're going to be using a feature on here we haven't used before, which is we have a part on our TI-84 that deals with just distributions. And what we're going to deal with is this command, which is for normal distributions. So it's to find the area under a normal curve. So this is going to be number 2, because you're going to see 2 of them here, though. So there's normal PDF and there's normal CDF. So what we can do with this particular one is we don't have to necessarily convert things into z-scores. What we can use is the lower bound of the area that I'm looking at. So if I'm looking at a particular area, we're bound on 2 sides by x values. It's those x values that we're going to enter in. And you're going to put a comma after everything. Then we are going to need the mean of that area, and we're going to need the standard deviation. And then we'll close parentheses. So we're going to need these parts here. So if you remember, we had these questions earlier. We were talking about that lengths of pregnancies are normally distributed with a mean of 272 with a standard deviation of 9. And we were asked, what was the proportion of pregnancies that lasted less than 259 days, lasted longer than 280 days, and the proportion that made it full term, which was between 252 and 289 days. So what you'll end up doing is you notice right here it says vars, and right above it says distribution. So right under the circle that moves us around, we're looking for this distribution. So that means we hit second and vars to get those distributions. And we're going to move down to number 1. Okay. So the first one here, remember that we're looking at less than 200 and, oops, would be on the side of my mean, less than 259 days for distribution centered at 272. So what we need is they need a lower bound. So if you're not getting the screen here, remember one of the things you can do is go into mode and make sure your stats diagnostic is off and your stats wizard is on, because we fiddled with those earlier. That might throw some things off at this point. Let me go back to my distribution again. There we go. So what we want to enter here is you want your lowest bound on this area. So this bound, remember this area keeps on going and going and going forever and ever and ever and ever and ever. So usually the bound that we put on it, if we're going less than, is this lower bound is going to be -1. And that says e to the 9,000. We discovered probably all you have to do is do a -100, and that will get you where you need to go. Or even if more, you could just type in like 1,000. What I was trying to do is get you as close to like going out to infinity as far as you can. So remember negative, and I'd say just put as many zeros as you can in there. As a point where it's going to be diminishing return, it's not going to be making much of a difference. If we go to the top will be 259 binding the area, because that is the maximum I can have. Now remember, the mean of my distribution is 272, and the standard deviation is 9. So we enter that all in, and we go to paste. So it puts it all in there for us, and we hit enter. And we get 0.0743. So pretty much what we had when we did this with the z-table. So as you see here, I changed this first number to 100, and as you see, I'm still getting that same score. So if you did check the z-table told us something very close. It said it's going to be 0.0749. So the problem is that the z-tables, because there's some rounding involved, the probabilities will be close, but it's not going to be exactly the same as you're going to get with a TI-84. All right, so for the next part, oops, what we're going to do is, let's clear this. Same issue as we're going to go second vars, go to number 2. And now this time we're looking for a different area. Apologies, my writing pad just was not working. So in this case, we're looking for a greater than area. And what we're looking for is, because we're lasting longer than 280 days, we're looking for longer than 280. So we're looking for this area. So when we're trying to think where we want to top this off at, well, this time, like I said, we're just going to just put something there, one with as many zeros as we can after it, like we did over here, except we had negative because it was a lower bound. So this time, because it's an upper bound, let's put my first lower bound in first. We're bound below by 280, and now we're going to bound above by 1 billions, trillions, billions, whatever we need. We just put tons of zeros in it to make it work. Mean is still 272, standard deviation is still 9. We hit enter, go to paste, hit enter, and it's going to give me that area. So it gives me the area up here. Like I said, once again, this is going to be a little different than what we would have seen if we used a z-score. This is 0.1870. And then we do want to do this very last bit here. We're looking in between two z-scores. So we're looking in between 252 and 289. So we need that area in between. So in this case, when we're bound between two areas, this one's going to be a little easier. We don't have to do any special thinking now. My lowest boundary is going to be 252, and my upper boundary is going to be 280 or 298. And the probability that I would have a pregnancy that lasts somewhere between 252, or my X is going to be between 252 and 298, will be approximately 0.8949. And I believe this one was a little closer to what we got when we used the z-table. All right, and like I said, we're going to do this one more time with the dogs. Okay, so if we're going to do the TI-84, like I said, all we need is we just need to know the mean. So the mean lifespan of dogs is 13.42 years. They have a standard deviation of 2.36. A is just want to know what is the probability that a dog is going to live less than 10 years. B is the probability that I'm going to find a dog and it's going to live for greater than 15 years. And then C is the probability that the dog will live somewhere between 10 and 15 years. So let's go to the TI-84 again. So the first problem is the less than problem. So we're bound between 10 and whatever is out here. So we'll pick -1 and as many zeros as we can right after it. So we're trying to get just going out to negative infinity. So second bars, we want to go to number 2, normal CDF. My lower bound will be So remember using this negative down here, -1, and then just start entering in zeros. And then we're going to put in 10 here. Our mean now is 13.42, and my standard deviation is 2.36. So we have to just change all that information. And that's approximately what we had last time. So the probability that a dog will live less than 10 years would be 0.0736. So what your TI-84 is doing is very similar to those t-tables, except it's actually the t-table used the formula for a standard normal curve to figure out these probabilities. Basically, this has that curve already built into it. So it has the formula. All right, so for B, we're looking for that greater than area because we're looking for the probability the dog lives for 15 years or more. So my upper boundary is going to be a 1 followed by as many zeros as I can. So once again, we're going to go to second bars. We're going to hit clear on that, and we're going to put in 15. And then 1 and as many zeros after as my upper boundary. Being a standard deviation, we don't need to change those in this case. And that's about what we had last time with our t-table or z-table. Sorry, there is a t-table. We haven't got to that yet. The probability the dog lives longer than 15 years is 0.25. And this one rounds a little bit. Last time was 1.5. This is 1.16. And then my very last one is I'm bound between the two scores. So bound between the 10 and the 15. So we go to our bars, go to number 2, and now my lower boundary is going to be the 10, and my upper clear is just the 15. Same mean, same standard deviation. And we get approximately 0.6748. Can't remember exactly what this came out on the t-table last time, but I know it was very close to that. All right, so just a little bit more practice of the TI-84. So example 7, we got different situations, and we're going to figure out these proportions. So for my first one here, a normal population has a mean and standard deviation of a mean of 3 and standard deviation of 1. We want to find the proportion of the population that is less than 1. Well, I'm pretty sure it's going to be 50%. But if we put this in our calculator, what we're going to do is we're going to do normal CDF. And you are going to have in there, because we're looking less than, it's going to be the -1 followed by as many zeros as we can. Then we're going to upper bound it at 1. Then my standard deviation is 3. And my mean is, my mean is 3 and my standard deviation is 1. So right below it, a normal population has a mean of 7 and a standard deviation of 5. We want to find the proportion of the population that's between -2 and 10. So we do normal CDF, except this time what we're going to enter in is lower bound would be -2, upper is 10. My mean would be the 7, and then my standard deviation is the 5. So we'll put this all in the calculator in a bit. So over here, the top on the right, we have a normal population. It's going to have a mean of 40, standard deviation of 10. We want to find the proportion, the probability that a randomly sampled value is greater than 53. So 53 is my lower bound, and then my upper bound is 1 followed by as many zeros as I can plug in. Mean 40, standard deviation 10. And my last one here, the bottom on the right. So we got another normal population with a mean of 56 and standard deviation of 12. We want to find the probability that a randomly sampled value is between 60, and 80. So we put in 60 and 70. Then we put 70 because those are the bounds on the area. The mean is 56 and the standard deviation is 12. So we go to the TI-84 here. So we're going to keep going, like I said, second bars, and then we go normal CDF. So my first one, we're going to make sure we put in a -1, followed by as many zeros as I can. Just keep going for a while. The upper boundary is 1, the mean is 3, and the standard deviation is 1. Oh, sorry, my mean is 3. I do not know why I thought this was going to be 50, but I thought my mean was 1. Yeah, it's not going to be 50%. This is 0.023, or let's round to 4 places, 28. So 0.0228. So for this one here, we're going to go second bars, go with our second one again. This time, my lower bound was the -2. The upper bound in the area is 10. The mean is 7. The standard deviation is 5. And that's going to be 0.68. Well, if we round it to 4 places, 6898. So as a reminder, because this is the area that is essentially less than 1, so the probability that x is less than 1. This was the probability that x was between the -2 and that 10. Okay. So over here on the other side, this is the probability that I would do, because we're bottoming out at 53, but then that is a 1 followed by several zeros. That means we're looking at an x value that has to be greater than 53. So we're looking at anything above 53. Second bars, we go to the normal CDF. So we put in 53, then 1 followed by as many zeros as we can. Then we'll put in 40, then we'll put in 10, and then we enter. So that probability would be 0.0968. And then for my very last one here, this is an area that is going to be bound between, or an x value bound between 60 and 70. And it has a mean of 56 and a standard deviation of 12. So second bars, normal CDF. This time we put in 60 as my lower bound, 70 as my upper bound. My standard deviation, or sorry, my mean is 56 and my standard deviation is 12. So that probability would be 0.2478.